The following section is about periodicity. It is talked about the physical or chemical properties of elements among the periodic table. First of all, what is meant by periodicity? It means the pattern will repeat in every time we go across the period. That means we can find the element with similar properties, no matter chemical or physical, when we move along the periodic table. Take this as an example. Now, in our daily life, we will face Monday in every 7 days, or you may say in every week. This is a good example for periodicity because when you travel along the calendar, you will find Monday in every 7 days. Of course, in our periodic table, we will focus on 4 major characteristics or characters. They are bonding and structure, melting point, atomic size, and conductivity. The first one is bonding and structure. In grade 10, you have learned already. For metallic element, they will get metallic bond and the structure will be giant metallic structure. While for the non-metallic element, they will form covalent bonds with either simple molecular structure or giant covalent structures. And here we have a periodic table. Now, in our discussion, we only focus on the period 2 and period 3 first. I have highlighted the periodic table. You can see the one with blue in color, they will form metallic bonds, and one with pink in color, they will form covalent bonds. The element with white letter, they form metallic structure. The yellow letter, they will form giant covalent structure, and the green letter will form simple molecular structure. So we can see, except several examples, for example, boron, carbon, and silicon, we can conclude almost every element in non-metals section, they will form simple molecular structure. For the atomic size, they will become larger in size when moving down the group. Here shows an example. In group 1, lithium will have the smallest size and rubidium will get the largest size. They are different only in the Period number, and here shows the reason. Because when they move down the group, they get more and more electron shell, and this increases the distance between the outermost shell and the nucleus, and then increase the size. When we travel across the period, the atomic size will become larger when there are weaker attraction between the nucleus and the outermost shell electrons. This is the basic principle. And now we get a conclusion. Across the period, because they get same number of electron shell, so we can conclude they have similar atomic radius, and we use sodium and argon as an example. For sodium, the outermost shell, each electron will be attracted by 11 protons, while for argon, each outermost shell electron will be attracted by 18 protons. So, with our previous page, we can conclude that argon will experience larger attraction from nucleus by the outermost shell electron because they get more proton. So the radius will decrease across the period. The third point we are going to discuss is the melting point or density. For metal, it is talk about the metallic bond strength. Here we have sodium and aluminium as an example. Because aluminium got higher charge density, it got 3 plus in charge versus +1 in sodium ion. The second, as we mentioned in the previous page, the aluminium ion's size is smaller. So we can conclude that the aluminium ion will get higher charge density, and hence there should be stronger attraction between the aluminium ion and the mobile electron, and this will increase the bond strength and the melting point and density of the metal. And that's why you can understand why sodium is so soft that it can be cut by a knife, but aluminium cannot. How about the non-metal part? The boron, silicon, and carbon, as we mentioned before, they got giant covalent structures. So the melting point is high because they got network of covalent bonds. You have learned this in grade 10 of even grade 9, so I will not repeat again. How about the other elements? For example, phosphorus, sulfur, chlorine, and argon. They got simple molecular structure, so only weak van der Waals force between them. And how can we compare or predict their melting points? One sentence is so important is the intermolecular force strength should be increased with the molecular size. And here we got the data from scientists. Sulfur got the highest melting point and argon got the lowest. And this makes us confused why the boiling point or melting point do not increase with the atomic number like this trend. But the reason behind is the element exists as molecules but not atoms. And here we show the real molecules of several elements. Phosphorus exists as P4, sulfur exists as S8 sulfur atom joined together by covalent bond to form a molecule, and chlorine as Cl2 and argon as monoatomic element. Because the molecular size is sulfur got the largest one, then comes with phosphorus, chlorine, and argon. So the melting point also follows this trend and as our observations. Finally, we come to the electrical conductivity. Now, you have learned that metal and graphite are good conductors and non-metals are insulators. The reason behind, once again, you have learned in grade 10 metal because they carry mobile electrons, while non-metal, they do not. So non-metals are insulators. But how about the comparison in the metallic conductivities? For example, sodium and aluminium, which one got higher conductivity? So we need to study their metallic structure again. Here shows a diagram. And I know that maybe some of you will predict which one is a better conductor already, right? Aluminium, we can find there are many electrons around the metal cation compared with that in sodium. So aluminium should be a better conductor. So we can get a conclusion. For the metal, when they get more mobile electrons, they will become better conductor. The situation about silicon is a bit complicated because silicon is a semi-metal. So their conductivity should lie between the metal and non-metal insulators. Their conductivity will be better in higher temperature. This is a bit weird and we will not discuss in the DSE level.